Hey guys, Justin from Fat Robot here. Today we're going to look at closures in JavaScript. And if you're new to JavaScript or kind of getting going on JavaScript, you may have heard about closures. And closures, people tend to talk about them as this thing that's like this big milestone when learning JavaScript. People will say like, "Oh, I remember the first time I realized how closures worked." And really, they're not that complicated. I think they almost seem more intimidating than they are because the way that people talk about them sometimes. But once you realize kind of how they work, it's really pretty simple, but they're very cool. And in fact, closures in JavaScript aren't that unique. Anytime you create a function, you technically create a closure. But it's how we exploit this concept of closures that is the really cool part. And so we'll take a look at that. I'll tell you right up front, the big cool way that we exploit this concept of closures is just basically returning a function from a function. That's it. Now you know closures. But there's a couple things you need to understand to see why that's cool and why we would do that and the ways that we can exploit that. And it really comes down to scoping. And so scoping, if you don't know, just refers to kind of where variables are visible to other things in JavaScript. And JavaScript uses functional scoping. So basically what that means is that anything that is defined within a function, any variable defined within a function, or I guess, in our case here, we have another function defined within a function. Any of that stuff is only visible within this function. Anything outside of it can't see that. And an easy way to think about this is that things in JavaScript can look outward to access other things, but they can't look inward. So they can't look into functions to find other things. They can only look outside. And so what we have here, this is the global scope. And this is just the top level of anything in your JavaScript document. So anything that's not nested within a function is going to be in a global scope. And that means, so any variable declared in a global scope, anything within the entire JavaScript document will have access to that. And you might say, well, then why don't we just declare all of our variables in the global scope and then you don't have to worry about it? And in a small trivial program like this, that might make sense, but it's a really bad habit to be in because as soon as you start building more and more complex programs, it gets really hard to keep track of all your variables, and it becomes really easy to accidentally overwrite a variable that you didn't mean to because you use the same name, especially when you have multiple people working on a project and maybe multiple people working on different modules that will eventually all come together. It just becomes insanely easy to overwrite things, and there's some security issues with that too. And so just as a good rule of thumb, try to avoid declaring variables in the global scope, period, if you can. I can't think of a good use case off the top of my head, but surely there's times where it makes sense. And in fact, in our function or in our program here, I have some declared out in the global scope. These variables here are declared in the global scope. But again, this is just a trivial program and it's here for illustration purposes, so it's not a big deal. But typically you want to declare variables only where they need to be accessed. Only allow visibility to those variables to the things that need to access them. And so, yeah, that's just a good rule of thumb to follow. So knowing that JavaScript uses functional scoping, that's kind of our jumping off point here. And so, again, like I said, kind of the cool way that we can exploit the concept of closures in JavaScript is when we return a function from a function. So we'll just start here. Here I have this function. This whole gray area represents this whole outer function body, this function outer here. And this is declared in the global scope. And inside of it, we have this variable counter. So this is a scoped variable. Basically, if we tried to access counter somewhere out here, we can't. We could declare a new variable called counter and it wouldn't interfere with this one. But we don't have access to this anywhere but within this function. And so then the other thing we've done, within this outer function, I declared a function called inner. And what that does is console logs out the counter variable, which basically, if you don't know, if you were running this program through like your terminal window, that just prints it out to your terminal window. So it prints out the value of this counter variable, which I've arbitrarily set to 100. So it logs that out, and then it decrements it. That's that minus minuses. It just subtracts 1 from that. And then, so that's this whole inner function body. And then the last part of this outer function is it returns this inner function. Okay, so pretty cool. Like nothing too crazy special there, but and so now what I've done is I've declared 3 different variables here. One is new function 1. Let me zoom in a little bit. So we have new function 1, and it is equal to a call to outer. And so again, a call to outer returns inner. So it is going to spit out this inner function into that variable. And you can see that illustrated over here. This is what's happening. Here's this outer function body, and it's going to make a copy of this inner function, spit it out into that variable. And so now we could say new func1, open paren, close paren, and that'll essentially call this function, or call the copy of it that is now stored in this variable. So we can use new func1 as if it's a function, just by putting the open and close paren. And so I've done that 3 different times. So I have new function 2, new function 3, and these are all calls to outer. And so each one of these gets a copy of this inner function. So still nothing too crazy interesting. But now, like I said, we can call those variable names as functions. And so we call new function 1, and it does, what we have. Oops, I forget I can't highlight things in this. It does this console log of counter, and we get 100 out in our console. So right away, that's kind of interesting, right? Because this is able to access the counter variable. Even though this is out in the global scope, we have access to the counter variable up here. And so that'll work. And then we call new function 2, and now we get 99, call new function 3 98. And so you can see what's happening here is, we'll zoom in a little bit on this. Not only do these have access to this counter variable, but they all have access to the same counter variable. It's not a copy of it. They're all accessing the same one. So each call to these affects the same variable. So that right there is the cool part of closures. We're basically making a way for these functions that exist out in the global scope to have access to a scoped variable, and they all have access to the same scoped variable. Which can be really cool. Kind of a classic use case of this is, say you had, like a venue, a concert venue, and say that concert venue had 400 total seats, and then you had, say, 3 different sections. You had the mezzanine, you had general admission, and say like a VIP area. Well, I could say variable VIP is like, equal to a call to venue. Variable mezzanine is equal to venue. And so every time we sell a ticket with one of these, we could call those functions, and they would probably decrement their own values for how many seats each one of them had, but then they could all decrement the same total seats. So you can keep track of exactly how many tickets you sold for the total amount. It's kind of a weird example, but just an easy one off the top of my head. So yeah, I mean, that's it right there. That's closures in action. And just for illustration purposes here, I put counter equals 50 and then another call to new function 1, and you can see that this counter 50 didn't do anything because this doesn't have access to that counter variable, but new function 1 still does. So it didn't reassign it to 50. It's still working off of the same value, or the last value that we had for it. Go just slightly deeper with kind of why that happens. Another scoping term that JavaScript uses is called lexical scoping, which basically means that like this variable exists where it is defined. It's not moving around as, calls to this function happen or anything. It's always going to be right here. And so when we're calling these inner functions, they're lexically scoped to be here. So for all intents and purposes, they just assume that they're right here. And so they have access to this. So that's kind of how that works. You can look a lot more into that to get a much better explanation, but this is just kind of a brief overview. But so basically, that's the big hubbub. You can return a function from a function, and you could do it multiple times, and all those functions will have access to the same variables, and they can each manipulate them, and each one will see the changes from each other's manipulations of those variables. And you can use that in really powerful ways. That's one of the cool features of JavaScript, or so I understand from watching Douglas Crockford lectures. I'm still definitely not good enough of a programmer to be like, here's an awesome way you can use those. I just know how you could do it for a concert venue. So just really quickly, I've set up kind of a similar thing here in CodePen, and I'll put a link to this so you can play with it yourself. But I have this function called closure maker, again, just with a counter. And then this inner function is just called closure, and it increments the counter variable, and then it returns the counter variable. And then the last part of the outer function returns this closure function. So, I mean, this is basically almost exactly like what we saw in my little sketch graphic there. So we're going to do 3 different variables: closure 1, closure 2, closure 3. Each one of these is a call to closure maker, which returns this inner function closure here. And keep in mind, we're not calling this inner function yet. We're only calling this outer function, but it's this that gets returned into these. And then I have it set up with a little jQuery here that when we click these buttons, it will run that inner function, this closure function that is now assigned to each one of these. So we have run closure 1, run closure 2, run closure 3, and then here we will output the value that is stored in that counter variable. So run closure 1, right? Closure 2, closure 3, that. So, nothing too crazy about it. But on my website, I'll put some links to some cool articles that really describe a lot more in depth kind of what's going on under the hood, and should give you an even better understanding of it. There's things like the call object that come into play and stuff, and that's just a good thing to understand, just to really understand what's happening in JavaScript in general. But yeah, I mean, that's it. That's the brief overview, and now you know closures. So there you go.